In this video, we're going to learn how to multiply rational expressions. Remember that with rational expressions, they're just fractions, so treat them the same way you treat regular simple fractions. When multiplying fractions, we just multiply across. So we multiply our numerators 2 times 3 to get 6. We multiply our denominators 3 times 5 to get 15. Just multiply straight across. Notice in this fraction, 6 over 15, we can reduce it to 2 over 5 or simplify it to 2 over 5. We can get the answer easier if we remember to cross cancel. So, if there are two numbers diagonally across from each other, like 3 and 3, they can cancel with each other because 3 divided by 3 is just 1. So we can simplify then, and then our answer is just 2 over 5. Same thing is true for algebraic expressions. I like to put parentheses around these algebraic expressions to remind myself that they're being multiplied. Remember, I can't cancel over addition. I can only cancel over multiplication. So in this first example, I can cancel out the x plus 2 and the x plus 2, and I end up with 5x over x minus 3. The last thing I have to remember to do is state values that have to be excluded. So a value has to be excluded if the denominator is 0. So the denominator cannot be 0, which means x minus 3 can't be 0, as well as that x plus 2 that I canceled. So I have to remember to look back at things I canceled out because those can't be 0 either. So the x plus 2 in the denominator also can't be 0. So my excluded values then are x can't be 3 and x can't be negative 2. In my next example, again, the first thing I'm going to do is try to cross cancel. So I notice I have an x minus 1 in the numerator and denominator. I can cancel those. The 3 and the 6, I can cancel to become a 1 and a 2. And let's just rewrite this so it's a little bit neater. Lastly, a squared divided by a is really just a times a divided by a. So I can cancel out an a each, or I could have just done that in this step by canceling out to make this a and this 1. So finally, I'm left with a divided by 2. And now I'm going to check for excluded values. So in the denominator, it cannot be 0. So x minus 1 can't be 0. Gives us x can't be 1. And this 6a can't be 0, which means a cannot be 0. So those are our two excluded values. Many times, you will need to factor your expressions to see if you can cross cancel. So it's not always going to be obvious. Try to factor first. It's a lot easier to cancel before you multiply. So factor first before you multiply. So let's go ahead and factor each expression. So this x squared minus 25 is the difference of perfect squares. So I'll make that x minus 5 times x plus 5. And in the denominator, I'll just leave that for now as 10x squared. And I'm going to multiply by factoring out the GCF from 15x plus 20. The GCF is 5, so I'll take it out of 5. And when I do, I'm left with 3x plus 4. And now I'll multiply this last expression by what multiplies to 15 and adds to 8. Well, that'll be 3 and 5, so I will factor that to x plus 3 times x plus 5. Now let's see if we can cross cancel or cancel anything. So I can cancel the x plus 5 and the x plus 5. I also can cancel this 5 and 10 to become a 1 and a 2. Now let's see what we have left. So we have x minus 5 times 3x plus 4 over 2x squared times x plus 3. And lastly, I have to remember to multiply everything out, so I'm going to FOIL the numerator. So I will get 3x squared plus 4x minus 15x minus 20 all over 2x squared times x is 2x cubed plus 6x squared. And lastly, I'll combine like terms, 3x squared minus 11x minus 20 all over 2x cubed plus 6x squared. And there's my answer, but I'm just going to make sure I state the excluded values. To look for the excluded values, I'm going to look back to where I first factored. None of these things can be 0. If x squared can't be 0, that means x can't be 0. If x plus 3 can't be 0, that means x can't be negative 3. And if x plus 5 can't be 0, x cannot be negative 5. So there's our excluded values, and there's our answer. Let's try a few more examples. So the first thing we're always going to do is factor. What multiplies to 18 and adds to 9? That will be x plus 9. Oop, nope. That will be x plus 3 and x plus 6. In the denominator, I have x plus 3, and then I have 1 over x plus 4. Let's cancel and then multiply. So x plus 3 can cancel with x plus 3, and I'm left with x plus 6 over x plus 4. Finally, I'm going to state my excluded values. So I'm going to look back to when I first factored everything out. X plus 3 can't be 0, so x can't be negative 3. X plus 4 can't be 0, so x can't be negative 4. There's my excluded values. In part B, again, let's try to factor first and then multiply. So I'm going to factor out a 5, get x minus 6. In the bottom, I'll have x minus 6. I'm going to factor out a 5 from this term as well. So 5 times x plus 3. Now I'm going to cancel. These two 5s can cancel. These two x minus 6s can cancel. And I'm left with 3 over x plus 3. Now I'm just going to look back to where I first factored everything to find my excluded values. X minus 6 can't be 0, which means x can't be 6. X plus 3 can't be 0, so x can't be negative 3. Let's try 2 more. Factor first, what multiplies to c and adds to b. So I'm going to end up with p plus 8 times p minus 4. Again, factor the bottom to p plus 9, p minus 4. Now I'm going to factor this next part by taking out the GCF. The GCF of 9 and negative 27 is 9. The GCF of p squared and p is p. And I'm left with p minus 3. And in the bottom is just a p plus 8, which I'll put parentheses around. Now let's try to cancel. I can cancel out the p plus 8 and the p plus 8. I can cancel the p minus 4 and the p minus 4. That's about it. So now I will write this out. 9p times p minus 3 all over p plus 9. I'm going to multiply now, so I'll distribute. I'll get 9p squared minus 27p all over p plus 9. Finally, I have to look back for excluded values. Look back to where you first factored. If p plus 9 can't be 0, then p can't be negative 9. If p minus 4 can't be 0, then p can't be 4. So you're just solving for p. And if p plus 8 can't be 0, then p cannot be negative 8. There's your excluded values. One more. So let's go ahead and factor first. So we have k plus 5 times k plus 6. In our denominator, ask yourself what multiplies to 60 and adds to 16. Well, that's going to be 10 and 6. in this next one, we have to factor out our GCF. So what goes into 9 and negative 45? Well, 9 does. And so we'll take on a 9, and we're left with k minus 5. And then on the bottom, we'll have k plus 5. Next up, we have to cancel. These k plus 6's can cancel, and these k plus 5's can cancel, which leaves us with 9 times k minus 5 all over k plus 10. Now multiply. Distribute to get 9k minus 45 all over k plus 10. Last up, let's check for excluded values. Check back to where you first factored. K plus 10 can't be 0 because that would make the denominator 0. We can't divide by 0. K plus 6 can't be 0, and k plus 5 can't be 0. So that means our excluded values are negative 10, negative 6, and negative 5. If we plug those back in, we'd be dividing by 0. So that's why there are excluded values.